everybody's left done with their multiple choice. Okay, before we start notes, just a reminder, we're now into December. We are running out of time in this semester. So if you've been waiting to do reassessments or if you've been waiting to do test corrections, you need to start. The time for waiting is over. Don't wait until the last minute. December 14th is the last day. That is a week from this Friday. So you have this week and next week, and that's it. So don't wait until the last minute. Get these things done. This week we do have advisory, so I have Wednesday is kind of filled up, but you can still come in before and after school. Okay, so take advantage of those times and get this stuff done. Don't wait until after the 14th and go, are you going to do extra credit? Because I need to get my grade up for the final. It's not going to happen. This is it. So that's your warning. Okay, so we've been talking about probabilities. We're going to continue with that today. We're going to have some new formulas that we're going to introduce. So these formulas, I'm going to go over with where they are on the formula sheet and everything, so you'll be able to find them. But they go along with what we were doing last week, but it kind of adds to it. So first of all, we're going to look at what do these symbols mean. So you might know what that symbol means when it's a U. Union. That's a union. It does kind of look like a parabola. Thank you, Matt. So this is used if it is an OR. So if it's A or B, you write it like this. That symbol is called the union symbol. That's when we use it, is for an OR. So if you want to write that on there, this is if it's A or B. And that symbol is called the union symbol. Sometimes you'll see A union B. People will say it that way. So. Okay, when we look inside, so we're going to come up with what we call the general addition rule. So this is one that you can use for any addition problem, any OR type problem. So our rule is probability of A or B is equal to the probability of A plus probability of B minus the probability of A and B. So this one means or, this means and. I'm going to write that to help you distinguish between the two. Not too close with it. So if we're looking at what this would look like as a Venn diagram, we would say here's A and B. And this part in here is our overlap. That's contained in A and it's contained in B. So this is what we refer to as our overlap area, where this is the A and B. So when we're looking at this A and B, that's what we're talking about, is this area in there. Right, but I'm just saying to understand what that means, that part that we're subtracting. Because what happens is when we talk about probability of A, we're talking about this entire circle containing A. When we talk about probability of B, we're talking about this over here. So that overlap, we counted in both. So that we will talk about that, but yeah, not yet. So this part of the formula is saying we've counted that part in A and we've counted it in B, so we don't want to count it twice. So we subtract it out here so it doesn't get counted twice. So be careful. Not to double count overlap. Because people have a tendency, and the way we were doing it before is we said if it's A or B, we add them together. But not if they overlap. Not if there's something that could be in both, then we don't just do A plus B. We do A plus B when we subtract that part out that was counted twice. In general, if we're talking about A or B, this is referring to either A or B or both. So the both is always included in the or unless it's otherwise specified. Sometimes they will say, what's the probability of A or B occurring but not both? So sometimes they exclude that part, but usually they don't. So that's implied that it's either one or both. On this other side, where it talks about disjoint and mutually exclusive, what do those things mean? You remember we talked about this last week. There you go. So this is when events A and B cannot occur together. We can have one or we can have the other, but we can't have both. So this one, there would be no overlap. And look at this, we could have, here's A, B, and there's no overlap. If it's in A, it's not in B. If it's in B, it's not in A. Cannot occur both at the same time. So, an example of this. Senior and sophomore. Can't be both. If you're a senior, you can't be a sophomore. If you're a sophomore, you can't be a senior. So these would be disjoint. If we had senior and male, well, that can happen. Okay, you can be a senior and you can be male. So this would be not disjoint. Can they both happen at the same time? If they can't, then it's disjoint. So if A and B are disjoint or mutually exclusive, then the probability of A and B is 0. Cannot happen. And sometimes they will put one of those on there and they'll give you a description of two things happening and they'll tell you that they're mutually exclusive, but then down on part C they may ask you what's the probability of the two events both happening. And you're going to look at it and go, you're going to want to use this, but if you do, it's not going to work out right because they're disjoint. They may give you a probability of A and a probability of B, and you could add those together and get a value, but if they're disjoint or mutually exclusive, that intersection, where they both occur, should be 0. Okay, so don't fall for that trick of trying to get you to give a number other than 0. Any other questions on that part? Okay, let's look at this next part. This line means given. So this is what we call a conditional statement. So if they ask you to write a conditional probability, this is what they're talking about. It's something with that given statement. Okay. So inside, conditional probability. Probability of A, B, so it's A with a line, then B, or B with a line and A, or whatever, two things that you're talking about. So you would read this as probability of A given B. So as we said, this is a conditional statement. Which means we place a condition that must be met first. So, when you see one of these, it's going to be, the question will be prefaced by something. So, examples of that, we may say, of the plane M&Ms. What is the probability of getting green, or something like that. So it's saying we're only looking at these type of M&Ms, and then we're finding a probability for that condition, for that type of M&Ms. We may have had data about several different kinds. We are looking at just that one. Another example, we may say, if the student is a senior, and then find some probability. So if the student is a senior, what is the probability they park on campus? If the student is a senior, what is the probability that the student is female? Something like that would be a conditional, because we're only looking at the seniors and then we're finding a probability within that group. Okay. So often you'll see something like that at the beginning of the question, and that's going to tell you we're talking about a conditional probability. So this is where we're looking at a specific subset of data. So those will tell us how to recognize we're doing a conditional probability. So to actually carry it out, we're going to have our conditional rule. So this is our formula for defining a conditional probability. So if we're doing probability of A given B, we do the probability of A and B over probability of B. If we switch those around, and of course we know probability of B does not equal 0, so we don't have to worry about division by 0 because we were told B already happened. So since it has happened, that probability is not 0, so we don't have to worry about dividing by 0. If we switch it around and find probability of B given A, we would have probability of A and B over probability of A. And we would know that probability is not 0 as well, because it has happened. So it's good to note that the denominator is the condition in the subset of interest. What I mean by that is whatever is out here is the condition. That's going to be what goes in the denominator. When we're given B, probability of B is in the denominator. When we're given A, probability of A is in the denominator. So that can help you keep track of how do I know which one goes where. Well, it's always both on top, the overlap is on top, and then whichever one you were given is in the denominator. If you look at the blue formula sheets that we have, you'll see over on this side where it says probability, there's our general addition rule. So that first one that we wrote down up at the top of our foldable, there it is. Okay. This conditional rule, here it is. Now they don't give you where it's B given A and A given B. They just give you one. They just need you to know that these two are the same. So whatever you're given is the denominator. If it were changed, you would change the denominator. Okay? So these are given to you. You just need to know how to use them. Questions up to here? Okay, let's look at the bottom part. Now this one, we get our general multiplication rule. This comes straight from our conditional. So if I were looking for this probability of A and B, if I know these other two things, I can find that numerator by just multiplying by the denominator to the other side. That would solve for the numerator. Same thing down here. I can take this, multiply it to the other side, I get the numerator. So that's how we come up with this general multiplication rule, is just from that conditional rule. So this one says probability of A and B is probability of A times probability of B given A. Or, if we use the other formula, probability of B times probability of A given B. Right, multiplying them. So these are just a rewriting of the conditional rule. So on your formula sheet, neither of these are given to you. They expect you to use this conditional rule and just plug in the two that you know and solve for the one that's missing. Okay? So they just expect you to do that algebra step to solve for that numerator. So that's why I like to show it to you as of the conditional rule being used, because that's how you have to look at it on the formula sheet. Now, on the front, I haven't done this yet. So this is the and this is called the intersection. Now, another thing that's good to note, you can use the general addition rule as well. That general addition rule to find probability of A and B. As well. So what you would do is use the formula for which you have the other information. Okay, so either one of these formulas here can be used for A and B because it's a part of each one. So it just depends, were you given a conditional probability or were you given the or? Whichever one you're given is going to tell you which formula to use to solve. Okay? So either one of those can be used to solve for that intersection. So, this idea of independence is going to come back up. We talked about independent and dependent when we were looking at the segmented bar graphs, and we were comparing them, and we said if they're different, they're dependent, if they're the same, they're independent. That same idea is going to come back here. We're going to be able to look at two different events and see, are these events independent or are they dependent? So, the idea of independent says the knowledge of event A, meaning what happened, the outcome for event A, does not give me any knowledge of event B. So, for example, if we're talking about event A and B being, it's raining today and I'm carrying an umbrella. Those are probably related. I'm probably more likely to carry an umbrella with me when it's raining than when I'm not. So if I know whether it's raining or not, I'm going to know how likely it is that I'm carrying an umbrella. Okay, so those are not independent events. Now, whether it's raining or not, and whether I'm wearing red clothing, those really are not related, because whether it's raining or not has no bearing on what color of clothing I'm wearing. But it does make a difference in whether or not I'm carrying an umbrella. Okay, so that's what we're looking at here. Knowing what happened with the first thing doesn't make the other one any more or less likely to happen. That's the idea of independent. Okay? So we have a calculation that we'll do to check for independence. So our calculation says if A and B are independent events, meaning one has no effect on the other, then we can do probability of A and B is just probability of A times probability of B. Because normally the general rule would say we would use the conditional here. But since the probability doesn't change if A happened or didn't happen, this value is the same as its conditional, because the value didn't change. When we knew A happened, it didn't change the value of B. So, more specifically, the probability of A is the same as probability of A given B. Or for B, the probability of B is the same as probability of B given A. So whether we know the other one happened or we don't, it's the same probability each time. So these are what we use to verify independence. So if they ask you, are these events independent? This is how you would show that you have checked that condition. And you can do for either one. You don't have to do both. Just show either probability of A is the same as A given B, or probability of B is the same as B given A. If you show one of those is true, then you have shown they are independent. If you're showing they are not independent, same thing. You would just show these are not equal. So anytime they're asked, you're asked to say, are these events independent? This is what you're going to do to check one of those two. Questions? Okay. Let's look at your problem set. Since you're not asking questions, I will see how you can do this. So this first one, we're given the probability of A, we're given the probability of B, and we're giving the probability of A and B. They want us to find the probability of A or B. So this is that general addition rule. Okay? So this says, to find it, we do the probability of A plus probability of B minus the probability of both. That's our general addition rule. So then we would just put in the values that it tells us. It says the probability of A is 0.6, probability of B is 0.5, probability of A and B is 0.2. And then we just calculate that. So 0.6 plus 0.5 would be 1.1, minus 0.2 would give us 0.9. And that's our probability. Questions on that one? Does this make sense to you? If we're looking at probability of A given B, this is where we do probability of A and B over the B goes to the bottom. Probability of B. So A and B is 0.2. Probability of B is 0.5. So it would be 2/5 or 0.4. Start out of 5. For number 2, they give us probability of A, probability of B, and then the probability of A or B. They wanted us to find the probability of A and B. So this is one where we have to use one of the other two rules, either the general addition rule or the conditional rule. Well, I am not given anything about a conditional, so I need to use the general addition rule. So that's going to say the probability of A union B equals probability of A plus probability of B minus probability of A. That's my general addition rule. Then I just plug in the numbers that I know. I know A is 0.2, B is 0.4, and A union B is 0.5. I'm looking for this A and B. Just put in the values that you know and solve for what is left. If I add this 0.2 and 0.4, I get 0.6. When I subtract that over, I get negative 0.1 equals negative probability of A and B. If I divide both sides by the negative 1, the probability of A and B is 0.1. Questions? You guys are so quiet today. Alright, part B. How will I do this? I'm going to use my conditional rule. So what goes in the numerator? Good. What goes in the denominator? Yeah, whatever I'm given, that's going to go in the denominator. So probability of A. So probability of A I was given was 0.2. Probability of A and B, well, that's my answer from the last question, 0.1. So sometimes you're going to use a previous answer to get to these. So this is going to be 0.5. Okay, I'm going to let you guys work on these, see what you can come up with on the rest of them. Remember, there's a front and back, so don't forget about the back part.